All right, everybody, we are live here for the virtual SunChase event. We're getting everything set up. We have videos from Dunbar, High, and Hardy, and we'll be ready to go right here at noon once we're ready to get started. If anyone has any questions before that, please feel free to throw them in the chat. And yeah, it's going to be a fun day. If I resize this, is that gonna? Do 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 do. Oh my lovin', I will send to you. All right, we're getting close to the start of the race here. Doesn't seem like we have any viewers right now, but we're still going to get started right at noon, and this video should stay up for those that are watching post-production. Thanks everybody for participating. We're getting ready to get started now. Again, we are targeting noon for the start of the virtual race, and we'll have the side-by-side video of both Dunbar and Hardy, and we'll see how things go. So, quick note, I have not pre-watched these videos, although I did look at the spreadsheets to look at the official times, but we'll release those after the end of the stream. All right, let's go ahead and get started. I've got a few seconds to noon. And in 3, 2, 1, they're off.
Go.
Slight desync there. But we have both carts off. Now I'll remind everyone that the lap distances for each car is a little bit different. So one lap for Hardy County is a little less than a half a kilometer. And for Dunbar, it's a little more than a half a kilometer. So by the time Hardy goes around once, we should see Dunbar not quite finishing their first lap. until after that, assuming that they're probably approximately the same pace. We got Hardy coming around here. Looks like they're about to finish their first lap. And we'll get an idea here after Dunbar completes their first circuit what our head-to-heads start to look like. Dunbar's coming around. I believe they're going to go past their starting point, turn around, and then we'll get them in for their first lap. Looks like Hardy's coming around here. They're about to finish their second lap. Indeed, we got 2 laps for Hardy. Dunbar's got quite a little bit more circuitous course here, having to do a lot more turns than Hardy is doing, and that's going to hurt their speed. You'll notice here that in this portion of the video, when they come around these corners, they are having to slow down quite a bit. So that's going to make it more challenging for them as this race goes through. Looks like they're about to finish their first lap. Coming up here, got Hardy on the third, and Dunbar is coming up on their first lap. Yes, we got it in. All right. So as we're going through, this is the first heat of 4 heats, so plenty of time to make up distance here. And it looks like Hardy is traveling quite a bit faster than Dunbar, but again, differences in courses here make a pretty significant difference. If you watch the speed that Dunbar has here coming into the turn, they are really slowing down quite a bit, and I'm not sure if they're having to use brakes on this or if they're just coasting through those turns. Hopefully they're coasting through those turns to try and save as much battery as possible. Hardy finishing their 4th lap. We'll see if Dunbar can close some of the distance as they get a little more accustomed to their course. Also, if you guys have any feedback or comments in the chat, feel free to let me know. I can rebalance audio here. I'm actually going to turn the audio on Dunbar down a little bit, get some of that background noise filtered out. It does look like Dunbar is making up a little bit of difference. They're getting close to finishing that 2nd lap. Hardy coming in for their 5th lap. Again, that hairpin turn right at the end of this parking lot is really slowing Dunbar down quite a bit. But look at the speed that they're going to get on this long stretch on the back here as they come in and get through their 2nd lap. By the time they get to the end of this course, they're really going. I don't have a live tachometer on these, so I don't know what the speeds of the individual cars are, but I would bet that that speed on the Dunbar car is well and above the average speed of the Hardy car. The Hardy car on their track is able to maintain a nice consistent speed, though, while the Dunbar is having to slow down for those turns. Hardy coming in for their 7th lap. I don't have a backup here, so if anyone's seeing a missed lap in the chat, be sure to let me know. I'm trying to watch both these at the same time, but so far I think we're okay. Hardy coming in for the 8th lap. Puts them just past the halfway point. And Dunbar coming in for their 3rd lap. Again, still a little under the halfway point. Although it does seem like they are making up some of the distance or some of the speed differential between them and Hardy. Thanks again to Rob and to Jana. You know, them and their students really putting a lot of effort into these, and we'll be taking a look at the students' presentation videos in between the races after we get both karts done. For those of you who are not familiar with the SunChase race, these are solar-powered go-karts. They have a minimal amount of battery power, but they're able to use, and so they can have up to 900 watts of solar panels. And the goal of the race is to try and maximize the speed over a series of 4 6-kilometer races. We've adjusted the distances and the battery capacity allowed for these races as time goes on. And the karts have been getting faster as we go year over year. As the teams get better at building the karts, they get better efficiencies and are getting through with the 4th lap here on Dunbar. They'll pass that halfway point right after their next lap. Already coming in on their 11th lap. Again, this will be a 6-kilometer race. And we do have official recorded times for each of these karts that we will confirm with our videos here. But there are live lap counters on each team for the official counts. Hardy coming on the 12th lap. Dunbar will be finishing their 5th lap here in just a few seconds. Dunbar on their 5th, Hardy finishing their 13th lap. I think that may have been Rob there telling them to go and go, go. Push them through as they're finishing up that last lap. I think I may have missed a lap on there. Again, as they get that, the 14th, their 14th and a half lap is their finishing point. Lap 14. So this one here on, sorry about that, on Hardy will not be a complete lap. They don't need to go all the way around. They need to just go through about 3/4 of the course, and they'll have finished their race. And you'll see them there. I think their finish line is right about that cursor. Dunbar coming in on their 6th lap right here. And there they go. That should be their finishing point right there. So Hardy has finished after just about 10 minutes through the race. Dunbar a little over halfway, coming in soon. Now the karts will have about a half hour, really a half hour from the start of their race, so 20 minutes from now, Well, they'll use their solar panels to continue to recharge the batteries. The solar panels are charging batteries throughout the entire race, but they want to try and make sure to keep those panels in as much sun as they can, and they'll have the second heat of the race here starting in about 20 minutes. Let's see if I can pull up that official time for Hardy. Dunbar coming up on their 7th lap. Make sure I get that in there. Hardy looks like they're getting ready. They got themselves a nice spot close to their tent. They'll start to recharge their cars. Excuse me. Total time on the Hardy race ended up being 9 minutes and 30 seconds. That will be their official time. Dunbar still going strong at this point. A little less than 14 minutes through the race, coming up in here on their 8th lap. And still going pretty strong. Hurting them on that turn. Let's try and watch this video and see if we can get a good idea of how much speed they're getting on this straightaway. Seems like they have slowed a bit on that. Not quite as quick as they were at the start of the race. You can see there the Hardy team is checking out their kart. They're actually cleaning off their panels, trying to make sure there's no dirt or debris that might block the sun. Trying to maximize their efficiency. Also trying to make sure everything stays cool. Those panels are more efficient if they're cooled off a little bit. So you may see them go out there with blowers or fans and ways of trying to supplement and increase their charging capacity. Dunbar coming around their 9th lap. Slowing down quite a bit on that turn. I'm not sure how much of that is their car. They're worried maybe about hitting the wall there a little bit. That was a little bit of a scary turn there, a little wide. Seems like there may have been some concern there with the cart. Coming in, gonna finish that 9th lap. It looks like Dunbar may be stopping there at this point. Yes, and it looks like Dunbar is stopped. All right, so overall for the first race, we have Dunbar in the lead, finishing their 6-kilometer sprint in 9 minutes and 30 seconds. Dunbar just coming just shy of the full 6 kilometers with a time of approximately 16 minutes and 24 seconds. So hopefully we can look and see, maybe we can do a little bit modifications to the steering on that cart and get it wrapped up for the next heat. We do have about 20 minutes or about 13 minutes until the start of the next heat. We're going to do a little bit of movie magic and take a look at some of the presentations by the teams before we move on to the next race. First up, we'll have the presentation by Dunbar High School.
Hi, I'm Michael Krupik, and I'm a senior.
And I'm hoping you all hear this just
I'm
fine.
Aiden Emery, and I'm a junior. I'm Griffin Zengel, and I'm a junior.
I'm Michael Jenks, and I'm a sophomore.
So our main goal was to have a functioning go-kart. The cart that we started with, that we already had, was 7 to 8 years old, but we needed a new motor controller because we broke the old one. We rewired the whole system. We got a new brake system, new tires. We had to get new batteries to meet the FGCU regulations, and we added one solar panel. The cart that we started with, that we already had, here are some of the battery options that we brainstormed that we didn't end up using. 48 volts at 20 amp hours would not work because it didn't meet regulation. 6 volts at 60 amp hours would not work because our motor will not run effectively at 12 volts. And 24 volts at 15 amp hours would work, but we decided not to go with that option. That we didn't end up using.
So the battery option.
48 volts at 20 amp hours would not work.
Sorry, everybody, I'm getting feedback on this. Let me try redoing the audio and see if we can't get that fixed.
Our motor will not run effectively at 12 volts. And
Hi, I'm Michael Krupik, and I'm a senior.
I'm Aiden Emery, and I'm a junior. I'm Griffin Zengel, and I'm a junior.
I'm Michael Jenks, and I'm a sophomore.
So our main goal was to have a functioning go-kart. The cart that we started with, that we already had, was 7 to 8 years old, but we needed a new motor controller because we broke the old one. We rewired the whole system. We got a new brake system, new tires. We had to get new batteries to meet the FGCU regulations, and we added one solar panel. Here are some of the battery options that we brainstormed that we didn't end up using. 48 volts at 20 amp hours would not work because it didn't meet regulation. 6 volts at 60 amp hours would not work because our motor will not run effectively at 12 volts. And 24 volts at 15 amp hours would work, but we decided not to go with that option.
So the battery option we chose to go with is two 12-volt, 30 amp hour batteries connected in series. So that'll give us our 24 volts, and we'll also get 720 watt hours. And then they're secured by 3D printed hold downs, and we're using 2-gauge wire for the batteries. We have an auxiliary battery that powers the brake lights and the horn in case the main batteries fail or they run out of charge. That's also secured by a 3D printed tie down, and it's a 12-volt 5 amp hour battery, and it's also 60 watt hours. Our Kart weight is about 680 pounds. Next year, we plan on eliminating the back cage because it kind of has a little trunk in the back that's not like integral to the structural stuff of the car. Get new solar panels that are lighter than the ones we have currently, and they'll be more efficient. We want a new motor because that'll be lighter and also be more efficient. And then a lighter driver's seat, and the frame that holds up the solar panels now is made out of unistrut, so we want to use a lighter material for that.
So we have 3 solar panels in total, which adds up to 720 watts, 240 watts each. We have a maximum of 900 watts, so that leaves us with 180 watt lots, which is 20% of our total allotted solar energy. Using our solar, we calculate our solar efficiency, which is our wattage for a single solar panel over the area of a single solar panel, times the standard test condition of 1000 watts per meter, which is about 16% efficiency. Normal solar panels are from 13 to 18%. So it's an okay solar panel, but there are solar panels that get up to 20% efficiency. So you might want to get one of those next time. Things that can reduce efficiency is temperature, which we think is one of the main things that's affecting us, along with degradation, which reduces our solar panels efficiency by 0.5% every year. Incident radiation flux is also a thing that affects our efficiency, but that's pretty high in Florida, which is 5.5 kilowatt hours per meter squared per day. But there are places that have higher incident radiation flux, which is the max being about 7 kilowatt hours per meter squared per day. And pollution is also a major thing that can affect efficiency, since it can block a lot of solar radiation getting onto our solar panels.
And then we're using a Solar Boost 3048 to be our charge controller. It just takes the energy coming from the solar panels and regulates it while it's going to the batteries, so we don't overcharge the batteries and they stay stable and don't catch on fire. This is our system wiring diagram. It shows our 2 12-volt batteries in series. It's got the 250 amp fuse. It shows the throttle and how that's connected to the motor controller, and it shows how the motor's connected to the motor controller and just how everything's wired up. Our tires, we have 2 different size tires. We have bigger tires on the rear of the car and then small tires on the front. And then for our wheel alignment, we wanted to have a little bit of toe out, so the wheels will look like this instead of like this, and that just helps better steering and helps decrease wear on the tires. And we adjusted the toe out by turning the tire rods, and then we clamped the metal beams onto the brake rotors, and then we measured the distance between the front 2 of them and then the back 2 like across, so when the back was smaller than the front, we know we have toe out, and we have about half a degree of toe out on the wheels currently.
So we have a 24-volt motor with a 14-tooth small sprocket and a 38-tooth large sprocket, which gives us about a 2.71 gear ratio. And using this equation here, we calculated it out to be 591 motor RPM for our average speed. So we wanted to mess with the gear ratio because it decides our maximum RPM, and we know that less RPM equals less acceleration. So our strategy for this race was to maintain about 15 miles per hour so that we could complete the 24 kilometers in 1 hour. So we wanted to limit our throttle to 80%, so we didn't want to race for speed, because we wanted to be able to actually finish the race, since if we raced for speed, we would run out of voltage really quickly. So we wanted to get 651 RPM to do this, because that would be the RPM to get 50 miles per hour. But our RPMs will decrease after each heat due to battery drain, so we had to go a little less than that. So we also have a programmable DC motor controller, which we program using Ultrax, the Ultrax toolkit. And with this, we can change our speed and torque values based on our throttle. We tried a couple of different things. We wanted to reduce the torque near to the end because we wanted to level it off at 80% throttle, so that we limited our speed so we could race for longer.
Our voltage started to decrease as our throttle increases. If you were to push the throttle all the way to 100, there would be a large volt drop in the batteries. The heat would increase and the efficiency would decrease. So we had to limit our throttle.
So this is our safety stuff. We have an emergency power switch that kills the power to pretty much the entire system. So in case of an emergency, we can turn it off real quick and it should be a little bit safer. We have our 5-point safety harness that keeps the driver secure and in the vehicle at all times. And then our brake system, we have the two main brakes that are the main brakes that are connected to the brake rotors and the pedal. And then we also have an emergency brake that can be used if the main brakes fail or while exiting and entering the cart. Then we have our 3D printed parts that we use also for like our battery tie downs, holding up the throttle and keeping our emergency switch secure. And these are our drawing files for them. Oops.
Our future endeavors would be to build a new frame, get new solar panels that meet max regulation, and get a new motor. The motor we want is a brushless motor. It produces less heat and is more efficient. Our old motor got way too hot and we got to cool it off with blowers. Some of the more important things we need are some better front tires and more test data.
And these are the sources we use for all of our solar panel information and for controlling our motor speed via wiring diagram for it.
Thank you. Thanks for listening. Thanks for watching. Have a great day.
Thank you for that great presentation, team. Really look forward to seeing how this performs in the next race. I think we've got just about everything set up. So hopefully we're good to go on this next segment. It's just coming up on 12:30 here, so we're ready to get started. And again, if you guys have any questions or comments, please feel free to throw those in the chat. And let's get started on the next heat of our race. Again, this will be the second race. And again, a 6-kilometer race, both teams using the same tracks as previously. So we'll see how it goes, and hopefully we can see good performance on both the teams. I think you can all see from that presentation the amount of work and how much the students have learned by working on these projects. All right, ready, set, go. I'm just going to pause this and give a second for the for the Hardy team to sync up a little bit. There we go. Let's get some of the audio back in on these videos. I think that all of our audio is going again good. Turn my desktop audio back on so we have that going. Hardy coming around to the first lap here. Lap 1 complete for Hardy. Dunbar starting strong again. Already more than halfway through that first lap. Not sure if they were able to get some things tuned in on that kart between trials or if they're just pushing it harder on this second race. Let's see how they do on this hairpin turn. This hairpin turn has been a real sticking point for Dunbar High School. Again, having to slow down a lot coming through these narrow corridors. Hardy coming in through that second lap. If you guys remember from our first race, Hardy, I think, had finished their third lap before Dunbar had finished their first one. So Dunbar definitely increasing the speed on this second attempt. Yeah, much closer race so far. So this is getting interesting, guys. Sounds like based on the chat that Dunbar was not able to use their track course because they have a clay or a rubber course, which would not be good for your rolling resistance. Again, you want a nice hard surface to maximize your efficiency for these tires. Luigi wants to watch. This is Luigi, by the way. Hardy coming in on that fourth lap. Doing good, pretty comparable to their previous times. Maybe trying to pick up pace just a little bit here on Hardy's side. Dunbar again coming through that tight turn. Gotta be mindful not to hit any of those buildings. And very well done on that side for Dunbar. I think it's one of the better turns we had seen through that course so far. Hardy coming in on their fifth lap. Dunbar finishing their second. Still a tighter race. Dunbar definitely tempted here to speed up on that long straightaway, although that's going to hurt their batteries if they go too fast on that. Because again, you don't want to have to break through those turns. You want to be able to coast through and let your resistance, your rolling resistance, and your air resistance slow you down rather than using those brakes. Hardy finishing their sixth lap. Hardy coming in for their seventh. Looks like Dunbar might be going back down to more of their standard speed from the previous one. Should have put times on these things. We can watch all the timestamps. Dunbar coming in for their third lap. Still going strong relative to their previous times. But sometimes that might hurt you in the long run depending on how much battery you got. Hardy coming in on their eighth lap. Uh-oh, Dunbar seems to be slowing down a bit there. Still going along. Once those batteries start to get low, they drop off very, very fast. So the fact that we're still going on here, I think suggests that they probably still have some battery here, although they may be running off of solar power at this point if they've slowed down quite a bit. So we'll see how that's going. remember the presentation, they had mentioned that they did want to get new front tires on this kart. Again, having good tires makes a big difference for these races. Oh no, Dunbar seems to be slowing down again. Hardy coming in for that 10th. Seems like that sun may be bringing down a little bit. Notice it getting a little bit darker on the course for Dunbar. And maybe if they're running off those solar panels, that may not have been enough to keep them going. Does seem like Dunbar may be stopped at this point. There are awards for both fastest times as well as the overall times. At this point, Dunbar may be better off trying to save their batteries for the third race rather than trying to push it for both the second race here, give themselves a little bit more time to recharge. We'll see what they decide to do going forward here. Seems like the sun is coming up a little bit more, giving them some power to keep going. It's going to be hard to maintain a fast speed running off just the solar panels. Up and going again on Dunbar, sticking into it. He's definitely getting a little bit brighter out. It's going to be very hard to maintain speed running off just those panels, though. You really need the batteries to back yourself up and support you, especially through shady portions of the course, and really just to keep you going. Hardy's coming up on their 14th lap. Again, they'll do 14 3/4 of a lap to finish out their race. Looks like Dunbar's come to a stop again. They may be waiting for some more of those clouds to come by. Hardy on their last lap. And again, this will be an incomplete lap, so you should see them coming to a stop right after going around that 3/4 mark. Again, we'll see if Dunbar decides to try and keep pushing this through, if they're going to try and hold out and recharge their batteries for the next race. Looks like Hardy just got past that stop point, so they should be good at this position. Looks like they're probably just coasting up to the finish, so that way they're in a good position to start for the next race. All right. Great job on Hardy. We'll go to their official lap times and figure out how they did relative to the first heat. Does look like Dunbar is still trying to finish in that 4th lap. Looks like you might have heard that call out on the PA. Again, finishing about 9:30 on that race as well on the official times. And Dunbar finishing that 4th lap. So Hardy being very consistent race over race. Oh, I'm sorry, team. I was looking at the wrong time for the first race. The first race for Hardy was actually 9 minutes and 53 seconds. Second race was 9 minutes 30. That's why I'm getting the exact same time twice. So a little bit faster on the second heat here for Hardy. And you can again see the team out there doing maintenance on the kart, trying to keep those panels clean, cooling down the motor, cooling down the charge controller, cooling down the panels, trying to maximize their efficiency before they get started here for that third race. Dunbar here is still persisting, going through. Still able to go under just those solar panels. I gotta say, it's really impressive that we have that Dunbar kart still managing to persist and getting through these laps on just the solar panel power. You have 900 watts of panels, but that's their maximum capacity, right? They're only putting that out for a period of time, for a fairly short period of time. And your battery capacity is going to be comparable to your solar capacity, but the solar capacity has to get stretched out over the entire almost 2 hours of the race period. So they're running on less than half power. With this current configuration, if you tuned everything out correctly. Um, I'm not sure if y'all can hear the beeping coming off that controller, but I think that's when their capacity drops below the minimum capacity to run the motor. And they have to wait to get a little bit more charge in before they can continue. Looks like Dunbar may have stopped. At this point, they may be deciding to see if they're going to wait and try and recharge for the next race. Yep, it looks like Dunbar is going to go ahead and get reset up and use the remaining time to charge and try and develop a good set before the start of the next race. Let's go ahead and take a look at the presentation video from the Hardy School.
Okay, so today we're going to be representing the Hardy Senior High School Solar Go-Kart build from 2021 called Soul Train. Okay, so today we're going to be representing the Hardy Senior High School Solar Go-Kart build from 2021 called Soul Train. This year we only had 5 members, Jason Walker and Ethan Willis, both of which were seniors, Jesus Velasco, Maria Mugia, and I, Jacqueline Throttle, the 3 of us being sophomores. We did also carry over some of last year's help and contributors. Those are listed on the right. This is just a brief summary where we're going to be talking today. Hardy orange and blue, paint job, the weight distribution, potentiometer issues, solar panels, batteries, and testing. This is what our build looked at the end of the year. To get right into it, we had the Hardy orange and blue paint job. It took a couple of days of sanding and some good dedication to get those bright colors away from the bright yellow we had to start. Equally important, we had the weight distribution. For this type of car, you want to have a lower center of mass, and for that, we want to have a good panel angle and height above the car on bars we welded on. Plus, we wanted to shift a lot of the weight towards the back, to the rear of the car, because, as you can see on the left, we had uneven wear on the front tires. So to combat that, we wanted to center the driver's seat, center the steering wheel, and even push back the seat a little bit onto an add-on that we had for the rear tires, just to have a little bit more balance. And then right here we have 2 diagrams of our 2019 setup of our weight distribution compared to 2021 setup. We did use a little bit of weight over the year, and then we, as you can see on the left, we had a 46% weight on the front, and on 2021 we had 44% of the weight on the front, so we dropped. So we had the corresponding 54 on the left and 56 on the right, so we had that general increase in the weight in the back. We also wanted to have a weight distribution with and without the driver. So without the driver, 44% of the weight was in the front, and with the driver, that weight shifted to 47% in the front. So we want to know how to distribute that weight evenly, because the driver makes up 19.5% of the car's overall weight. So 2019 we didn't have a good weight distribution diagram with the driver, but we suspect there was also more weight in the front.
We were also having problems with our potentiometer. A potentiometer is a rheostat that works on resistance. Ours was causing our cart to jerk, and we suspect that corrosion or other foreign matter was interfering with the connection between the wiper and the coil, which led to energy waste. We were able to make a replacement, which is pictured here on the bottom left, and here are images of us working and modifying the cart. We also lost the use of our 2019 speed controller control box, and we weren't able to make a replacement due to compatibility issues. We also replaced our solar panels. Our old ones were 255 watts. We replaced them with 300 watts, which brings to a total of 900 watts.
After purchasing our new solar panels, we decided to go with some new batteries. What we went with were 2 VMAX 12-volt 30-amp-hour deep cycle batteries wired in series. This is just below on the little diagram of the batteries, how we have wired them up. Together, they give us 24 volts for 30 amp hours for a total of 720 watt hours, which is the allotted regulation for this year. This year, I also did a science fair project with the solar cart doing gear ratios to experiment which one would give us the best speed while also giving us the best amount of amp hours drawn, thus not killing our battery so quickly, but also giving us a good speed to continue competing. But in the process of this, I got a little carried away and I went too high of a gear ratio and I burned up the brushes in our motor. So the team and I decided to take another motor and take it apart since the brushes were good and replace those brushes by rebuilding the motor I fried. This is just a brief summary of everything. The gear ratio we decided to go with was a 40 to 13 to accommodate our new batteries, which are a little more special than our last ones, as they are made to be recharged from 0 to nothing, easily. which helps accommodate for our new solar panels of 300 watts. This is just a brief little diagram of everything we've done. Here's our paint job, our potentiometer over here, where we centered our seat, our solar boost, and the gear ratios. This next slide shows the back, our panels a little more, where our wiring's all set up, and our wide attachment for our wheels to help with the weight distribution.
This is our race simulation with 4 different trials, with me running the first, third, and fourth trials, and Ethan running the second one. There was about a 13-pound difference, which is shown here, and then the timing for the first trial being 8 minutes and 41 seconds, and the second one being 11 minutes and 2 seconds, and we think the time difference was because of the weight difference. This is the third and fourth simulation, and there was also a time difference down here, which we think was because of the weight. And then on the third trial, we used up most of our energy, which is why we think the speed on the fourth one was lower. We ran on March 15th, and it was light on the clouds and sunny.
So we did also want to do some endurance testing just to see what our battery was giving off. So a battery supplies a useful voltage. The 12-volt battery that we use provides a useful voltage from 14 volts to 10.5 volts, but discharges down to 12.3 to 12.5 volts. So we went ahead and decided that 12.4 was where we were going to call a dead battery. And if we kept using the battery below a dead battery value, then it was just going to impact it negatively.
We ran a test to get a useful battery curve and made a continuous run at a moderate pace, which was 25 kilometers an hour, or around 15 miles per hour, to determine the battery discharge.
For this test, we ran a continuous lap with a roll-by check of our voltage on our MPPT charge controller, which is the solar boost box on the side. And then again, every 16 laps, and we put a meter on the battery with the panels turned off to get values from there.
To the right is our chart for the MPPT, which is the roll-by check of the voltage on the solar boost. And at the very beginning, it was 29.1 and then 25.5 at the very end.
And on the left, we have our meter data, which is only about 6 points. But we could also see a general decrease from 27.3 to 24.8 volts. So we continued these runs until the battery reached the meter voltage of 24.8, which is where we considered a dead battery. And this is at lap 80, so we did really good. On the left, we have the meter data. That was, again, general decrease, but since it was only 6 points, it's a little bit less, but more accurate.
And then to the right is the roll-by check, which was a 16 points, and we also saw some bumps on there.
And we think those bumps were attributed to when the car was stopped and we were getting values and the car was able to charge up from the sun. So again, we were traveling at a relatively constant speed of 16 miles per hour, and our cart was able to run an hour and 20 minutes before the battery hit 24.8 volts, which we were considered a dead battery. Though in the video you can see it's not a fast speed, but it's pretty useful in urban situations or areas where you want that limited speed.
Race day, April 17th, 2021. The reason why we chose this on a Saturday was because it has the best weather for today. We chose these time intervals because this is the best time when solar noon is out, which is when the sun is at its highest, which is good for the solar panels. This is the race forecast. This is basically what was supposed to be on Saturday when we start the race. What we are looking at is the cloud cover to determine what is the best time to race. The race course is 14.67 laps around the Wildcat Stadium clockwise.
That is this year's Solar Go-Kart team for 2021. We thank y'all for watching. We hope y'all enjoyed it. And a big shout out to our sponsor, Mosaic, for allowing us to continue to do this, and we hope to continue doing this for the next few years. and we hope to continue doing this for the next few years.
All right, thank you to Hardy County for that wonderful presentation. Hopefully, as we continue to go through here, we will see increased performance from all of these teams over time. But I think that was a great explanation of their design process and the changes they made relative to last year. So again, very kind of you can see the effort that's being put in from both these teams and how it is a great learning opportunity for all of these students. We're a little ahead time, but we can use a little bit of movie magic to put these videos onto the appropriate streaming position. So we're going to go ahead and get set up for the 4th race. Not sure why my aspect ratio on the Hardy stream is so much different. Let's see if we can fix that a little bit. That looks better. All right, and I think we're set up and ready to go for race number 3. Let's reset the lap counts. And we can go ahead and get started for race 3. Try and sync that up just a little bit more. There we go. And we're off. And as these cars are going through these races, they are going to be using up their battery reserves. As they mentioned in the video, they did a continuous test on the Hardy School, but this discrete test where there's time to charge between the races means that you have more capacity to go faster because you're able to charge during those pauses between the races. So if you think about having a 700 watt hour battery, if you have a 900 watt panel, you can recharge that battery in about an hour. Now again, you're not going to get a whole 900 watts out of that for every single persistent because again, you don't usually typically have 100% solar radiation, and the panels are not always directly facing the sun, so you usually get a little bit less than that rated capacity. But again, going close to solar noon with minimal cloud coverage, you could fully recharge those batteries over an hour period, which means that you can use up about half of that battery per race and then have it recharged ready for the next race. Already coming in on their second lap. Dunbar going a little bit more conservatively this race. I think they probably realized that they were using up too much of their battery capacity in that first fast start on the second race, seeing if they can get a little bit more distance out of this third attempt. Hardy coming in on that third lap. Dunbar definitely taking a little bit easier here. Maybe they did calculations between races and figured out what speed they can maintain and try and finish this race. Hardy coming around for their fourth lap. You can see the tire marks as they've been coming through this turn. Not sure how much of that is them. Again, the rubbing coming through and coming around those corners, again, losing energy going through that tight turn, making it harder for Dunbar to maintain speed, and also cutting their efficiency down quite a bit. Hardy coming in on lap 5. Dunbar coming in on the end of their first lap for this third race. Still would be very impressive if Dunbar can maintain that speed and finish the 9 and change laps they need to be able to do to finish this 6-kilometer race. Already coming in on their 6th lap. It's important to note that last year, I think we had, well, not last year, year before last, we had 16 cars compete in the race. And this year, we only had 2 teams make it through to finish their karts and send in their videos for competition. So just the fact that these teams are here and racing and getting everything they needed to participate in this event is a significant accomplishment on the behalf of these teams. Already coming in for their 8th lap. Dunbar going through that tight turn again. Again, Dunbar going slower than the previous laps last time, but at much more consistent speed. So hopefully we'll get a better distance in this heat. Just finished the 9th lap for Hardy. And coming up here on the 2nd lap for Dunbar. Again, so maintaining a pretty consistent speed for Dunbar. Hopefully they're keeping that battery to the point where they'll be able to go through all 9 laps they need to finish this race. Again, any of you guys just joining us, this is the virtual SunChase Solar Go-Kart race. Hardy just finishing their 10th lap. And these cars are completing a 6-kilometer circuit using up to 900 watts of solar panels and a 700 and I forget what it is, 740 I think watt hours of battery capacity. Again, not allowed to recharge those batteries during the race or the time between races. So only charging off of the solar panels during the race period. Hardy coming in on their 11th lap. Again, these will be doing a series of 4 6-kilometer races, each race starting approximately half hour apart, giving the total race duration being just shy of 2 hours. The overall awards are based off of the time to complete the 6-kilometer races. So finishing early allows you to get a better time, but you still have the same total amount of charging time, regardless of when you start and finish. Got a little bit of commentary coming through on the feed from Hardy as they come in for their 13th lap. And the 3rd lap for Dunbar. At this point, I think Dunbar is catching up on their distance from the previous one. So hopefully going a little bit more conservative will allow them to get better distance and a better time ultimately throughout this race. And Hardy is going to complete their 14th lap here in a little bit. And then again, they need to do that just a little under a 3/4 of a lap to finish out race 3. They had that in their presentation there, and they need to do 14.6 laps. So as you see them come to a stop just as they get past that billboard, or at least start to drift and come in, just using the inertia. Sounds like they got 9 minutes 30 seconds from the announcer there on the Hardy feed. We'll compare that to their official times. Yeah, official time for race 3, indeed 9 minutes and 30 seconds. Almost exactly consistent with their time on the second race. So again, a very well-controlled and designed process there, going for a very targeted speed and maintaining that speed throughout the race. And again, we'll see Hardy come out here, check over the cart, make sure everything's clean, make sure things are charging, cool things off, try and get as much charge as possible between the finish on that current heat and the start of the next one. Uh-oh. Looks like Dunbar may be coming to a stop here. We'll see if Dunbar, oh, going again. Not sure what the voltages of their batteries are at the start and end of these races. Looks like they may have run out of battery power at this point on Dunbar's side. Going again. See if we can get around and get this lap finished. Come on, Dunbar, you can do it. Looks like we got a partially cloudy day on both the teams' fields here. Hard to tell exactly how much cloud coverage we're getting over the carts, but definitely not 100% sun for either of these teams today. Finishing that 4th lap and still going. If anyone has any questions about the SunChase Solar Go-Kart race, feel free to put those in the chat. Let us know if you have any comments about this year's race, or if you have any questions about how you can get involved for next year. Again, we do hope to have next year's race at the Florida Gulf Coast University main campus. We typically race on the main loop going around the campus, which is about 1.8 kilometers, and we'll do 4 laps, I believe, of that loop. I think that's right. Oh no, I'm sorry. I think it's 1.8 miles and we do 2 laps per race. Dunbar's still going. Still maintaining a reasonable speed. Looks like we're going about maybe 10 miles per hour on that side. Again, probably at this point running mostly on solar power. Doing their best to kind of keep speed around that. Oh, looks like our video on the Hardy side has run out on that race. We'll get that pulled over to their next set. And we should have a continuous feed for this. Sorry, gotta get that out of the other feed a little bit here. Dunbar still going around. Looks like they're going to get that 5th lap completed. I'm not sure if they're going to try and take a break between this race and the final 4th race of the season, or if they're just going to try and push through and get as much distance as they can out of this kart. I'll ask anyone that has any questions about the SunChase race as we're finishing up the 3rd heat of 4 races. Again, there's 4 6-kilometer races in this solar go-kart race. This is the latter half of the 3rd race. Dunbar High School is working on trying to finish, but they've just about run out of battery power, and right now they're going on just solar, or it seems they're going on just solar. And so we're going to get as much distance as they can out of this before we move on to the 4th race. These are solar powered go-karts that are built by the teams. They have up to 900 watts of solar panel capacity, most of them running 3 panels. And they're only using AGM or lead acid batteries, so not advanced battery technology. The goal here is to make this as much solar as possible. Looks like Dunbar just finished their 5th lap, and it looks like they may be waiting or holding at that position. We'll hold here for just a few minutes to check and see if Dunbar decides to try and get any more laps in for this third race. And then we'll get started for the fourth and final race of the season. I'm actually pulling up my rule book now. Wanted to get hard numbers for all those who are not familiar with the SunChase race on the requirements for battery and panel values. Both of these cars did complete a safety inspection prior to completing this. So there is a fairly long list of safety rules that they have to maintain for the drivers. Maximum of 720 watt hours, and we actually have decreased the battery allotment for these carts over the past several years to encourage the teams to push more towards running off of solar power and less off of that battery, and also to force them to be as efficient as possible and to keep the speed down, honestly, because these carts can get pretty fast. It does look like Dunbar is stopped at this point and probably waiting for the start of the fourth and final heat. All right, I think we're going to take advantage of our recording here to fast forward to the start of the fourth race, just to save a little time on the stream. And we'll key forward as close as we can possible to the same amount of time in both of these feeds, so we get to the start. We'll get Hardy set up, figure out where their start is. Little advice there for the drivers on the Dunbar side. There was the start on Hardy. Oh, we got past the start on the Dunbar side. Didn't quite get the start on that. We'll try and get that a little closer. There we go. And we're off for race 4 of the 2021 virtual SunChase race. Let's get our race counts reset. Again, Dunbar's had that time between races to recharge their batteries a little bit, although getting to a full charge, again, in that period of time is not feasible. So they may get up to kind of a quarter charge on their batteries. So we'll see how much distance they're able to get out of those batteries. And hopefully being pretty conservative with their speeds on this to maximize distance. Hardy coming around and finishing up their second lap. Hardy may be pushing it a little bit harder this race. Since this is the last race, they do want to try and use as much of that battery capacity as they can. No point in saving it for another race at this point. You're going to want to finish as close to zero as you can. However, you can't run out. So you can make sure you have enough to finish at the same time, not getting to the point where you go so slow that you're running on fumes. So it's a delicate balance between pushing the kart as hard as you can while still having a little bit just at the end there. Coming up on lap 3. Dunbar getting around that hairpin turn and going for the end of their first lap. Dunbar finishing that first lap. Hardy coming in on their fourth lap. Dunbar going pretty good at this point. Still having a pretty good amount of speed on that back straightaway. Hard to know exactly how much. Oh, looks like we lost the video feed on Dunbar. That's lap 5 for Hardy. And looking at the race results for Dunbar, it does seem like they had a failure of a wheel. Looks like their passenger side front tire had a blowout, which prevented them from finishing the race. I'd like to thank the Dunbar team for putting in all the effort to participate this year. I think they had a really good kart. I'm sure that course that they had with all those tight turns had a significant impact on the wear for those tires, as well as the amount of battery that they were using in that first race. So hopeful to see them next year on a little bit more even playing field with some new tires. Already coming in on lap 6. Lap 7 on their PA, it sounded like. I'm not sure if my lap count got thrown off during that transition. Let's get Hardy's full screen in here and get a better view of what's going on with that feed. Try and get that count to stay in the right spot. There we go. And now it's showing that video is going with lap 8. I'm going to assume that I missed one and go ahead and increase my count on this. We do have a GPS stream from the video, so we can confirm that they did indeed complete all 6 kilometers of the race. And we can go back and double check this if you want. But I think I probably missed just that that lap when we had the Dunbar stream come out. So we'll go ahead and watch this and see what the final time for the Hardy team was, and we'll get a cumulative total time for them. Finishing lap 10. Again, Hardy is going to complete 14 and a little under 3/4 laps to finish out this race. Again, for our viewers here, thanks for tuning in. And if you have questions, feel free to put those in the comments. You can always also contact me through DLURA@FGCU if you want more information about the SunChase Solar Go-Kart race. And if you'd like to participate, again, this event is held in Fort Myers at Florida Gulf Coast University on an annual basis. It's lap 11. Lost tracking of the video there, of the kart there for just a few seconds. Lap 12 for Hardy. It's a little over 2 more laps to go. Coming up on lap 13 here. A little over 1 more lap to finish on this. Coming up on lap 14. At this point, probably pushing the kart about as hard as it can go. You've reached 0, you can always drift into the end. Come on, Hardy, let's push it. You can see the team members there racing towards the finish line. Cheering on the team members. Go, 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 go. Getting that final time in there at the end of the lap. And that should be it. And the count on the official spreadsheet confirms a 9-minute 0-second total time for the race 4 for Hardy. Going through here, again, their first lap time, 9 minutes and 53 seconds. Second and third, 9 minutes and 30 seconds. And last one, 9 minutes even. For a total race time of 37 minutes and 53 seconds. So Hardy will be our winners for the 2021 Solar Go-Kart Challenge, SunChase. And our runner-up, Dunbar. I'd like to thank both the teams for participating this year. And feel free to reach out to me if you have any questions or concerns, or if you'd like to get involved for next year. At this point, we'll be ending the stream, and we thank everyone for watching, and especially the students and the teachers for participating and helping to make this event a success. Have a good evening or afternoon,